Hi, this is Dan Coates from ECE 554 from the summer 2018 session, and this is my project, which I call the Sunrise Alarm Clock. So let's jump right into the main user screen. So here I used an LCD, which would be the main display that the user will interact with. So this will be where the user gets all the information from, much like a normal clock. The time you see ticking, it's at an accelerated rate now just so that I can do that for demonstration purpose. Every minute is about a second right now. So you can see it's counting up as it should. The top display is the actual time. For the time, I decided to use a 24-hour format as opposed to a 12-hour, just based on personal preference. And then on the bottom here we've got the alarm time. So currently it's set to 6 o'clock. Excuse me. And with that, let's go ahead and go to the deeper menus here. To do so, you have to use these buttons here. So these three buttons are what you use to navigate the menus. This is the up button. You may be able to see the mark there I got. So use that to go up. The OK or selection button, your main button, and then the down button. So from the main screen here that shows the time and the alarm, you simply press the OK button. So I'll press it right here, and then it transitions you to the user setting selection screen. So these are the three different parameters you can set. The first one being your alarm time, and if I go down, this one being your actual clock time. Down again, you see that that's wake. And then I roll over, keep going down. You can oscillate through the menus here. But let's go ahead and set the alarm to something different. So I click OK. Then you see I got a pointer either on the alarm time or confirming the setting. So if I just wanted to leave it what it was, confirm setting. But let's go ahead and change it. So click OK. See it says hours. So let's set it to, let's say 8. Click OK, and then now we're at minutes. Sorry, the alarm had reached its wake up, which we hadn't gotten to yet, so I just shut it off real quick. So now we're at minutes. Go ahead and set it up to, let's say 5. So 8:05 is when the alarm will be set. Confirm it, and then you see the alarm updates on the main display as the time keeps ticking away. So next, let's go down. This is essentially the same menu. So here you see the time. The only difference is as the time continues, you can see it's updating real time. So the time is still going, and you can see it updating until you press OK to change it. So here I'll set the hours. Let's go down a couple here. Go to 4, and then obviously minutes as is. Just confirm that. So that's the alarm and time settings. Let's go back to the menus again, and we'll go to the last one here. This is your wake, sunrise wake setting. So by default, this is set to 60 minutes, and what I have programmed is 30 different brightness steps. So if you leave it at default, when you go to the wake up routine, you will ramp up in brightness over 60 minutes. And since there's only 30 different brightness steps, every 2 minutes you'll go up another brightness level. And then obviously if you select 30 minutes, you'll go up a brightness level every 1 minute, or 90 minutes, you'll go up a brightness level every 3 minutes. And then obviously if you select none, there's going to be no brightness ramp up at all. So let's just go ahead and leave it at the default for now. That's 60. And then I'll change the time real quick here to actually show that. So the sunrise routine works in this way. Whatever brightness level you have, if you set it to 60, the default, since the alarm is currently at 8:05, at 7:05 is when the brightness ramp up will begin. And depending on the duration, which right now is 60, it'll ramp up every 2 minutes. If you selected 30 minutes, then obviously 8:05, 30 minutes before that is when you'd start your brightness ramp up, and then 90 minutes before that. So let's go ahead and change the time to make it a little closer to that. although actually it's fairly close. I'll just let it go then. So once we hit 7:05, I have the LED strip here, which functions as our sunrise LEDs. So when we hit 7:05, you'll see the LEDs begin to turn on, and every 2 minutes they'll become brighter and brighter. Since we set the setting to 60 minutes, every 2 minutes we'll get the brightness up. So once it hits 8:05, the brightness will be latched up to the brightest level, and the alarm buzzer, which I have down here, the little black cylinder right there, will begin to beep. So we're almost at 8:05, and you can see it's getting quite bright. There you go, and then the buzzer goes off. So to disable that, you have to use this button here. So this button functions as both the alarm shut-off and the early escape from the alarm, and I'll explain that a little bit more. So I'll go ahead and shut the buzzer off. The buzzer does sound a little odd too, due to the accelerator rate. Usually it turns on and off every second. So let's go ahead and change the time back to rerun through the sunrise wake up. So I'll go back here, set the time back to, let's go to just about 7. Okay, so we'll start the ramp up again at 7:05. You see the LEDs start to come on every 2 minutes, getting brighter and brighter. So what the user can do, say you wake up because of the LEDs here, you wake up earlier than the alarm. Maybe you don't want it to go all the way to full brightness at that point and the buzzer to go off since you're already awake. So what you can do is use this alarm button to also exit early. So we're not yet at 8:05, but I can press the button, which I just did now, and then the LEDs will shut off and the alarm will no longer trigger at 8:05. So once we get to 8:05, no buzzer will go off. And we'll just go back to normal operation. So then with that, here's the buzzer. I just got a little potentiometer. You can change the volume if you want it to be quieter, or right now it's at max volume, but let's go ahead and talk about the additional features that I added here. These were features that I wanted to add, time permitting, that I thought would be a cool add-on to the sunrise routine. So utilizing these two different sensors here, I've got a photoresistor over here and then a proximity sensor module over here. There's a couple different features that I added with this. So the first thing is that anytime the proximity sensor is triggered, so anytime something passes by it, this LCD, the LEDs in it will actually turn on. So right now, pass my hand over it, you see the LEDs actually turn on the LCD, and this will always trigger on no matter what disabled features you have. So the other feature I have is called night light or auto light. Even if you have that disabled, the LCD will still turn on, just so that the user, in the middle of the night may be able to see the LCD if they want to see what time it is, or just to make it easier to be able to see it even during the daylight. So this will stay on for about 30 seconds, and that's determined by the potentiometer setting over there on the module, the proximity module. You can change the setting for how long after a trigger it'll stay on. So I set it to about 30 seconds, and the LCD LED is already turned off here. So the other feature is what I call the auto light or night light, like I mentioned before, and that utilizes both the proximity sensor and this photo sensor. So right now we have plenty of light, as you can see. If I go ahead and cover this photo resistor though, so I'll just cover it with this lid here, this should be dark enough to trigger it. So this time when I pass my hand by the proximity sensor, the LED strip actually turns on as well. So this is a feature that you can both enable or disable. By default it's enabled, but right now in unison the LCD and the LED strip will be on at the same time once you pass by proximity sensor, since the feature is enabled. And just to show that that's the case, here I'll go ahead and trigger another 30 seconds here. If I take the lid off here, you see the LED strip goes back off, on, off. So this allows the user to have essentially a night light, a proximity to detect night light, in addition to the sunrise function, which I thought was a cool way to add what was already there just by adding another sensor. So letting that transition here, I'll go ahead and show how you can enable disable. So this yellow button is the standalone button for the auto light feature. So if I press it, it says auto light disabled, press OK. So right now it's currently disabled. Still got the photoresistors covered, so it should be dark. Pass my hand over it, and you see the LCDs, or the LED strip doesn't turn on. So you can disable the feature as well if you don't want it to turn on, especially if you're going to bed. I don't think you'd want the LEDs detecting every bit of motion and turning on in the middle of the night. So I'll go ahead and press the button again, turn it back on, and we're still within the 30-second duration, so it turns back on the LEDs. So that is, in a nutshell, most of the features here. I can also show the none function of the wake routine. So if I go over here, select wake, set it to none. This just allows it to have essentially normal alarm clock operation. So let's go ahead and set the time back to probably have to be around 6. Go back down. That should be good enough. So typically, if we had the wake function on the sunrise wake, we would expect at default it to start ramping up the LEDs at 7:05, but as you can see here, LEDs stay off, and it'll continue on to 8:05 and trigger the alarm, just like a normal alarm clock. You also have the ability an hour before the alarm, even with the wake disabled, to exit the alarm early if you do wake up early and don't want to hear the buzzer. So that allows for that. I'll wait till it gets to 8:05 just to show you the alarm going off. Meanwhile, while all this is going on, the auto light or night light feature can still be enabled, disabled. So if I pass my hand over it, see the auto lights are on. And the buzzer goes off at 8:05 just like expected. So I went ahead and disabled that. I'm going to take this off here. So that in a nutshell is all the features that I added. I can go over the hardware briefly here. The buttons are all momentary switches here, so just single push switches. So I had to debounce those as well as use resistors to pull them down. The buzzer here is just a 2-pin buzzer using voltage and PWM. So for the PWM for these lower current / voltage devices, I just used some transistors I had and then PWM them from the micro. Here is just a typical 16:12 LCD display. Another thing that I used from previous projects and other classes. For the LED strip, I actually had to power that off of 12 volts. So I needed something a little more substantial using that MOSFET there. And in order to PWM that, the LCD is fairly low current LEDs, so that I could use the transistor for. And then finally, the brains of the whole operation, the Arduino Nano that I used, controls everything here. So surprisingly, I was actually having spare pins. There's about 3 or 4 extra pins even with this tiny microprocessor, which I thought was pretty cool to be able to do with such a small module. But everything is controlled by that Arduino Nano. So with that, I'll just talk about briefly a couple things that I would change. Going over this, I do think it would be a nice feature to potentially add some AM/PM user functions as another menu option. Like I said, 24 hours is what I used, and for the sake of this and time, I just decided to go with that. The other thing, obviously, this is all breadboard form, so lots of wires and breadboarding. It's not the most visually appealing, so given more time, I think I could make it much more of a production-looking thing, using proto boards or making fixtures to actually put these different things in, but for the sake of function, this works just fine. So the only major issue that I've found is that the Arduino Nano has a inherent fault with timekeeping, and it's not something that I came across until I began testing pretty late into the process. So the Arduino Nano uses a ceramic clock, not even a crystal clock, which is even more inaccurate. And the issue with that is that the time that I've observed overnight, I can lose anywhere between 1 or 2 minutes. So it'll be behind by about 1 or 2 minutes when I wake up in the morning after about 8 hours or so. Which, if you set the clock before you go to bed, is not a big issue, but you can see as the days go on, that'll add up fairly quickly and be pretty inaccurate. So unfortunately, that's something that I could correct with software, but the issue with it is that the ceramic clock is very temperature sensitive, so I may add a software compensation for it, but if I moved it, say, upstairs into the heat, it'll be completely different with the inaccuracies. Maybe it'll be too fast at that point. So what really needs to be done is to use a separate module for timekeeping. This could be done either with there's some standalone timekeeping modules that use some DC batteries in order to keep the time, and they're very accurate from what I've seen. Unfortunately, I think just with the time that's left, there's not really opportunity to be able to add anything like that. So you could do something like that. I could replace the Arduino timekeeping with a separate module like that, or a GPS module even, if I really wanted to be spot on and keep in line with cell phones or computers like that. So that would be my major thing that I would fix with that. Other than that, all the features that I intended to work are operating as I wanted. So this is the end of my project presentation here. Thank you for watching.